In the first video, we added the college gripper from the iiQWorks.Sim eCatalog to our COP. We also created and started an instance with our COP. Let's open the instance project. Go to File, Open, Online. Select your laptop. We can observe that our instance is running and connected because of the green icon. Double-click onto your instance. Select the robot. Go to Configuration, I/O Mapping, and select Sim Signals as Scene Element. As we can see, the gripper model contains 3 signals: Action Signal, Closed State, and Open State. Go back to the layout. Start the simulation as local
in the Robot Controller Simulation RCS mode,
with no program selected. Open the connect signals for the college gripper by clicking on the gripper, then the lightning bolt symbol. The action gripper signal can be forced to true or false. We can then observe that when the signal is set to true, the gripper closes. The state signals are set to true when the gripper is in a given state. Using iiQWorks.Sim Advanced, we can also see the gripper moving. Let's map these signals. Go back to the I/O mapping editor. First, let's map KRC digital input and output to the digital I/O board. This will link the KRC variables to a physical pin. On both sides, select the scene element KR10 R1100-2. Select on one side KUKA system bus, KUKA digital I/O board, digital output command, bit 0, and KRC digital outputs, $out 100 on the other side. Click the chain symbol in the middle or drag and drop onto the other to connect them. Link KUKA system bus, KUKA digital I/O board, digital input state, bit 0 to KRC digital inputs in 101. Then link bit 1 to in 102. Now save the project. Export the Partial Fieldbus project by right-clicking in the Devices tab on the KUKA system bus and Export Partial Project. Deselect the KUKA controller bus from the selection and save the partial project. In iiQWorks.AppBuilder, right-click on Configurations, Fieldbus. Select Import Partial Project and add the partial project previously exported. Save the COP and export it. Let's reload our COP in iiQWorks.Sim. First, close the layout. Go to File, Options, Add-on Manage. Update the COP. Restart iiQWorks.Sim. Reload the layout from our instance. Delete the KUKA system bus sys x48 bus from the Devices Fieldbus tree. Update the My I/O Gripper COP version, and when the Import Fieldbus to Controller window appears, click Import. Deploy the new configuration onto the instance. Now the I/O mapping is here. In order to check our simulation, let's map the gripper signals to the KRC digital inputs and outputs. To do that, select from the scene element Sim signals, GRP backlinks action signal on one side, and from the scene element KR10 R1100-2, KRC digital outputs $out 100 on the other side. Click the chain symbol in the middle or drag and drop onto the other to connect them. Do the same for KRC digital inputs in 101 and GRP backlinks close state. Finally, connect KRC digital inputs in 102 to GRP backlinks open state. Save the layout and deploy it to the instance. To test it, click on the robot. Go to the KRL Executor tab. Select the Execution Mode Remote View and Simulation Mode Attach only. Start the simulation. Go to iiQWorks.Cockpit and open the instance Web UI. Go to the Inputs and Outputs page. Go to $out 100. Log in as expert and request the single point of control. Force the $out 100 to false or true. Observe the gripper changing state.
Thank you for joining us today. If you enjoyed this video, please like and subscribe the KUKA channel for more content. For practical training and workshops, visit the KUKA College. Stay tuned for more tutorials and insights.
Making automation easier.